everyone. Thanks for joining this barcamp. So today we're going to talk about Genymotion in a different context than the one you are probably used to use it. We're going to talk about Genymotion on the CI, and we're going to try to see how you can use the tools that we've introduced into Genymotion to make it work on your CI server. So I'm Flo. I'm a software developer working at Genymobile on Genymotion, and this is Antonin. He's the Scrum Master of the Genymotion team. A brief reminder of what is Genymotion. So Genymotion is an Android emulator. It's OSP based. We try to be as close as possible at what would be vanilla Android. We run on Mac, Linux, and Windows. And we are free for personal use, but we have a business license, an indie license, if you use it in a professional context. So you can see that we're running an emulator here. Yeah. The latest version we released is the preview of Android Marshmallow. It's pretty stable so far, but in the coming weeks we're going to have the fully functional Marshmallow version. So a bit of the agenda. I'm going to present you the different tools, all the way to Jenkins and how you can integrate Genymotion on your CI. And hopefully we have some time for some Q&A at the end. So to start with, we have the Java API. It's something we've introduced a while back already. It's just a bunch of API that you can use to control the state of the virtual machine directly from your test. So in your code, you can directly interact with the VM and change the battery level, fake an SMS receiving, fake a call, all that kind of stuff. So you can change the state of the system directly from your test and assert whatever you want to assert in the test. So there is an example. It's a classic activity instrumentation test case 2. You can see that we check that we're running on Genymotion, otherwise the API call would fail. And here, for example, we are faking the sending of an SMS, and then you can assert whatever you want after. So this is fully documented. There is an open source app called Binocle that is on our GitHub repository, so you can grab it and you can check whatever you can do with this Java API. Second thing is GMTool. GMTool was introduced a few months ago. It's a binary command line interface. So you can directly from the command line control the VM. You can start VM, you can create new VM, you can interact with all the different widgets Genymotion has. So you can also set the battery level, send mock data for GPS, this kind of stuff. It's part of Genymotion. So if you're running the latest Genymotion and you have a business license, then you can use GMTool already. Yeah. So Antonin is going to show us what it looks like. Hopefully the demo will work. So directly in the Genymotion repository, you have the GMTool binary. It's also all documented. If you go on the website, you can find full documentation. But all the commands are also documented, so you can just type in a command. We don't see what you type, actually. Okay. Yeah, so for each command, you have you can just put help, and then you can see an example of how to use this command. Yeah, like here, admin create help. All the commands are grouped in different families. So admin, for example, is to interact with the device itself. So here you can grab the list of all the templates for Genymotion available. And if we grab on Nexus, for example, then we get all the available Nexus template. This command line interface is very handy for scripting, for example. Yeah, so this is the preview version of Nexus 5X. And then you can create the device. Yeah, and then this is gonna grab the template from our repository, and then you're gonna have it locally on your workstation. So this is now creating the VM, basically. And now that the VM is created, you can start it. You can see that all the calls are blocking also, so it will only it will return when the device is fully launched. So you know that when it returns that your device is ready to be used. So it's now starting. Yeah. Here we go. We got back the command line, and the device started. So you can list all the devices that you have on your machine. You can see the status, and you see that the last one is on because we just launched it, basically. And from there, you can interact with the widget. Yeah. So setting the battery level to 9, not charging, and then the VM should react. You see that, yeah. Now the system believes that it doesn't have battery. You can also root the logcat. So if you want to grab the output of the logcat directly on a file in your computer, it's also possible. Yeah, and here you go. And then in there, you should see some log that says that the battery was the battery state changed, basically. Yeah. So this opens possibility for scripting everything and make it easy for you to put it on the CI because you don't have to use a graphical user interface, basically. So now we can stop the device again with GM tool. Yeah. And then you can delete it. So we've seen that we can grab a brand new device, fresh from our server, start it, interact with it, you do whatever you want with it, then you can stop it and delete it. And then your system is just as clean as it was before this started. Okay, so this is nice, but this would require you to write a lot of script, this kind of stuff. You are an Android developer, you use Gradle, you want to have something transparent and easy for you to use. That's why we made this Gradle plugin, which is basically going to leverage the GM tool binary, but directly in your build.gradle files. So the idea here is to be fully transparent, and so that you don't have to change anything to use Genymotion in your usual testing process. So if you're using the task connected Android test to run your integration test, this plugin is simply going to listen for it and start the VM when the connected Android task test is going to start, run the test on it, and then kill the VM and delete it. It's fairly easy to use. This is a build.gradle file. Add the plugin repository. We're on gcenter. Make sure you pull in the proper dependency, so Genymotion plugin 1.0. Apply the plugin. So this is very similar to what you are used to do with the Android plugin. And then define the target. You simply have to, in your build.gradle, define what device you want to use and whatever characteristic this device should have. There is a bunch of property that you can configure. So you can configure the form factor, the density. You can choose to flash whatever you would need to flash on your device before running your test. You can install APKs. You can root the logcat. You can define a lot of stuff. This is, again, all documented. You can grab online the documentation. You can check the Binocle project to see how this is done. And if you have more questions, you can also contact us through the support. Come to see us. We have a booth on the show floor. We'll be happy to answer any question. So let's see this in action. So we have the Binocle project. We're just going to edit the build.gradle file. So checking out master, editing the build.gradle file. So we add the dependency to start with. Then we apply the plugin. So the beauty of this is that it's fully transparent for you. You really don't have to change anything in your actual workflow. It's just about applying the plugin and then defining whatever device you need, and that's it. This then just works out of the box. So now that the plugin was applied, just let's define two devices. So on Linux, you need to set up the Genymotion path because we're not able, the plugin is not able to find it by itself. On Mac and on Windows, you don't have to do that, but on Linux, you need to do it. Yeah, and then we can start to define the devices. So next is 5. You can give whatever name you want for your device. This doesn't matter. What is important is what template you want to pull from the repository. So yeah, the template. So we're going to get a marshmallow preview. And that's it. This is the minimum stuff you need to put. You can put just this and it's going to work. But then you can also override all the properties that we talked about before. So now, if we run the connected Android test task, you're going to see the plugin kicking in at some point. So it's now building the project, getting dependency, and fail. I think in the dependency name, open the build.gradle file. There was a, yeah, you see? This is not good. Yes. Demo effect. Okay, let's do it again. Okay, getting the dependency, worked. It's now configuring. It's now building. And then we're going to see the connected Android test task started. And the Genymotion launch connected Android test is kicking in. The VM is going to start, and the tests are going to be run on it. So you really have nothing to change to your current workflow. That's what we wanted to do, to make it easy for you guys to integrate Genymotion in your process. We didn't want to have you to change the usual testing process you were using. We want it to be as transparent as possible. So the VM is starting. And when the VM will be fully started, we're going to see the test run on it. Yeah, so it's on. And now you can see that the connected Android test task kicks in, and the tests are running on it. By default, each device, each VM that is created by the Gradle plugin is going to be deleted, but you can choose to keep it if you want. You just need to override one property. If it makes sense for you to keep the VM around, you can do it. Okay. So the test run. Let's move on. Yeah. Okay. So now we've seen that we have the Java API to control from the test the state of the VM. We've seen GM tool to control, to be able to script whatever you want to do. The build.gradle, the Gradle plugin, sorry. Now, how this all integrates with your continuous integration server. Let's see. So first, a few requirements. Those are the Genymotion requirements. In order to be able to run Genymotion, you're going to need this configuration. What is very important here is that you need OpenGL 2.0. You need some RAM, 2 gig, whatever operating system, Linux, macOS, or Windows. And please, no virtualization. We don't advise you to run a VM inside a VM. We can't guarantee that it will work properly. And of course, you're going to need an X server, because Genymotion cannot run headless, but that's not the point anyway. Then you need latest version of Genymotion, so 2.5.0 plus, GM tool, a business license, and the Gradle plugin configurable properly in your app. So if we take Jenkins as an example, because we use Jenkins at Genymobile, but this applies for any continuous integration server you would be using. What we advise you to do is to add a slave node. So your Jenkins can run on whatever machine is in your office. But to run Genymotion, take a separate machine with an X server, quite some RAM. If you plan to run a lot of tests on a lot of different VM, you're going to need kind of a beast, like a good machine. So that's why we always use to use a slave node. You set up everything on this machine, and then on Jenkins, you can configure everything to say, okay, this project should be run on this machine, and it will just do the job. Also, on Linux, make sure that you export the display variable, because otherwise it won't work. Yeah, let's see how this goes. So we have a Jenkins running on this machine locally. Let's configure it. This is just a brief overview. If you want to go deeper into this, you can check out Jenkins documentation. Everything is also explained there. So go, yeah. So a few environment variable you need to set, the Android SDK path, and then the display variable, because we're running on Linux. Then we're going to create a new project. Yeah, freestyle project. Let's name it Droidcon Paris. We're using Git. You put the URL of the repository. So it's a local repository on the machine. So this is, like, again, this is standard. This is standard Jenkins. This has nothing to do with Genymotion. We're just showing you how to set it up. Okay, then you say what branch you want to build. And then you can say what task you want to run. So basically, if you already have a Jenkins, you already set up your project, you don't have anything to do. It's all transparent, because we're using the connected Android test task. And then we can kick off a build, and you're going to see the VM popping in. You can see the console output. Whoa, it's big. And it failed again. What happened? GM tool command failed. Ooh. Yeah. It's an ID problem, I think. Try again. This works, usually. It's just for the demo. No. I think it cannot ID you on GM2. Whatever. That's kind of the whole workflow that we have here. We have it on the booth, on the show floor, and it's constantly turning over there. So if you want to check it, you can see it live over there. Yeah, that's kind of it. So if anyone has questions, be happy to answer them. No question?
En passant, il y a un message d'erreur, mauvais login mot de passe là.
Oui, oui.
Okay. Est-ce qu'on peut rouler plusieurs devices en parallèle ou ils vont rouler les uns après les autres?
So the question is, can you run different devices in parallel? The answer is yes. You can run as many devices as your machine is going to be able to run them. Because the more device you have, the more RAM you're going to need, the more CPU power you're going to need. So it's possible, but it all depends on the machine. You can run them in parallel if you want, because you can, in the Gradle plugin, you can basically tie a device to a product flavor. So you can say, okay, for when I build this precise product flavor, I want to run all those devices. So you can do it, yeah.
Est-ce que les AVD sont compatibles avec les tests Espresso?
Sorry, can you...
les tests Espresso.
Yes, yes. So the question is, can you run espresso test on it? Yes. It's actually intended kind of for espresso test. This is all made for integration testing, so espresso is actually a very good use case. Yeah. Is it working now?
I have a quick question. Is AVS virtualization possible with Genymotion? So what I would like to do, I would like to drop dependency to physical machine, which will be running emulators, and I would like to put everything in cloud.
I don't understand, I'm sorry.
I would like to drop dependency from physical machine, which would be running emulators, and put everything in the cloud on the AVS. Is it possible? Did you test this use case?
I don't know, I'm not sure. I'm sorry.
The problem which I had with this setup was that running the lack of I need to have X server, and with Amazon is not that trivial to get it. And
so you want to run your VM on a server somewhere on Amazon, for example?
Exactly.
Well, you might run into the problem that they are doing virtualization already, and then you're gonna be running a virtual machine on top of virtual machine, and we don't advise you to do that.
But there was on one of the slides no virtualization allowed.
Yeah, exactly. That's what I'm saying.
Okay.
Yeah.
Okay.
You can try it, but we can't guarantee it's gonna work.
Gotcha.
Or that it's gonna behave properly. It's more. No. So you can grab the slide also at this bit.ly. And if you have more questions, you can come at our booth on the show floor, and we'll be happy to sort you out. Thank you.